This is Unit 2, Lesson 8, Calculating Rate of Change, and the objective is students will be able to determine rate of change. Rate of change is something that we've talked about previously, but we've used a different term to describe it. So let's start off with going over our vocabulary, and the first vocabulary term is rate of change. Rate of change is the ratio that describes how much one quantity changes with respect to the change of another quantity in the function. Another term used to describe rate of change that you're familiar with is slope. And we will be using the slope formula a little bit in this lesson, and that is m equals y2 minus y1 divided by x2 minus x1. Our second term is interval. An interval is a continuous portion of a function. So when we look at rate of change, often we'll be looking at a certain interval. So that means we're just looking at one section of the function and we're trying to decide what the rate of change is in that one section. The interval can be written by using brackets with AB on the inside. And A would represent the first x value that you're looking at. And then B represents the second x value that we're looking at. So we can write it inside brackets. Another way that we can write this is by saying A is less than or equal to x is less than or equal to B. So that A and B would just tell me pretty much whatever number we have here and here would tell me what the x values would be, and then we would use the y values that are associated with that point in order to calculate the rate of change. So there's 3 different ways that we're going to be doing this, really 4 different ways. We will be looking at rate of change from a table, from a linear function, from an interval of an exponential function, and then finally we'll be estimating the rate of change. So this table, the x values represent the year, and then the y values represent the number of households in millions. So that's 66 million, 61 million, 56 million, and then 51 million. In order to find the rate of change from the table, the first thing I need to do is select 2 points. Well, in this example, I want to calculate the rate of change over the interval 2008-2011. So that piece of information tells me that I'm going to use the first and the last x value, which means we use the first and last y value. So the 2 points that I'm going to be using are 2008 66 and 2011 51. My next step is to substitute those 2 points to slope formula. Let's start that out by labeling our x1 and y1, x2, y2. So I'm calling my first point, point 1, my second point, point 2. Now the slope formula is y2 minus y1 divided by x2 minus x1. You should already have that on your notes. If you don't, please write it down because you will be using it a lot today. So m equals, my y2 is 51, y1 was 66, x2 was 2011, x1 was 2008. 51 minus 66 gives me negative 15. 2011 divided by 2008 gives me positive 3, and that will simplify to negative 5. So if I'm trying to evaluate what the rate of change is in the number of households per year, I would say the rate of change is that it drops 5 million households per year. So calculating rate of change with a table, we just have to identify the x and y values that we're using and then plug them into slope. And that's a process that we're going to be repeating throughout this. Next, let's look at how to find rate of change from a linear function. The linear function that I'm looking at is negative 8x plus 6y equals 36. My first step is to transform this into slope-intercept form. Or in other words, my first step is to solve for y. This is a skill that we learned back in our first unit, and we still use this skill a lot. It's something that we're going to continue using a lot. So if it's something you're still having a hard time with, make sure you ask for extra help on this part, because it's something that you want to get very comfortable and quick doing. So first I added 8x, now I'm going to divide everything by 6. So when I transform this into slope-intercept form, I have y equals 8 over 6 will reduce to 4 over 3, and 36 over 6 reduces to 6. The second part is to identify slope, and slope is represented by the variable m. Remember, slope is also our rate of change. So I just need to look at this equation in the form y equals mx plus b and pick out which value is m. Well, m is the variable that's with x. It's the coefficient of x. So that means m equals 4/3, or my rate of change is 4/3. The next way we can find rate of change is by calculating it from an interval of an exponential function. The function that we are looking at is f of x equals 1,300 times 1 plus 0.026 divided by 12, all to the power of 12x. I know that this is an exponential function because up here you'll see that the variable is in the exponent. This function represents an investment of money. So I know that my answer is going to be in terms of money. So first thing I need to do is determine the interval. Well, I want to determine the rate of change from a 1 to a 4-year investment. And years are represented by the x value. So that means my interval is from 1 to 4. First step, I found my interval. In word problems, that will often be stated as, figure out the rate of change from this point of time to this point of time, or from this hour to this hour, or this day to this day. Next thing I need to do is create a table with x values from my interval. So my table is going to have x and f of x. And we could do 1, 2, 3, and 4, but really the only numbers that we need are just 1 and 4. 2 and 3 don't matter because they're not going to help us calculate the slope. So if you take this 1 and you plug it into this formula on your calculator, you will find out that when x equals 1, or f of 1, equals $1,334.21. And you'll find out that f of 4, or when x equals 4, equals $1,442.32. Oops, let's get that 2 on there. So I created my table by using the x values that were in the interval and then calculating the y values with my calculator. Next, I'm going to substitute those 2 points into slope formula. My 2 points come from the table, and they are 1, 1,334.21, and 4, 1,442 and 32 cents. So we have x1, y1, x2, y2. And when we substitute those into slope formula, we have m equals, our y2 is $1,442.32. Y1 is $1,334.21. And x2 is 4, x1 is 1. When you subtract in the numerator, we get $108.11 divided by 3 years. And that gives us a slope of $36.04. So if I'm talking about an investment here, I would say that my rate of change, the amount of money that is added to my investment, is $36.04 per year. Alright, let's look at our final example, and this is going to be